want you to take a triangle off the table. So everybody should have a triangle. We've got right, we've got acute, we've got obtuse. Okay? I want you to look at those, and I want you to think about what the relationship between the angle measures of the triangle might be. Okay? Think about those for just a second. Yes? Huh? Well, okay, what do you mean by that? Okay, use typically when you talk about substantive angles, it's only two. But yes, okay, they have that relationship. How do you know that? Okay, so you just knew that from past classes. Right? Anybody else know that already? Some of you did. Okay, so I want to model that for you. I want you to take your triangle, and I want you to tear off all three angles. Okay, now don't make a little bitty tear, make a decent little tear, okay? Alright, make a decent little tear, put them on your desk. Then I want you to put together all of the vertices. The vertices are the pointy parts, okay, where the angles are created. Put all those angles together, and I want you to see what happens. Okay, what do you notice? It's a hazard.
It's a hazard somewhere.
Huh?
It's like a hazard.
Where? Here? Okay, what those little orange, it's kind of hard to see because of the light. Put that on there. Okay. There, it's a little bit better. See how they make little tears? Okay? If you put them together, what do they create? Huh? All three of those angles, right? What do they create? When I say put all the angles together to where the points touch, what do they create? A line, right? And if you put all the angles together in a line like that, they should add up to equal 1/8. Okay? Alright? Okay. No, not the whole lesson. That's half of it. Alright, so, I forgot to get your notes too. If you're given two angles of a triangle, could you find the third one? Yes.
Yes.
Yeah. Now make sure that these triangles, the triangle trash, is into the trash can in a little bit. Not right now. Okay, so let's say that I made this angle right here 62, and I made this one 53. What would I do? Yes. Okay, so add these two together, which would be 115, and subtract 180, right? Okay. So what is 115 minus 180? 65.
Marty.
Okay. So 65. Now, let me ask you this. What if it had a right triangle, okay? And I told you that this angle right here was 50. What's this one going to be? It's going to be 40, and that's really easy to see. Even though we know they all add together to equal 180, if one of the angles is right, okay, what does that leave for the other two angles together? 90, right? So if one of them's 50, the other one's going to be 40, okay? All right, so now one little theorem that we have here before we state, this is called the angle sum theorem, before we state that. It says through a point, not on a line, so this point right here, not on this line, okay? Through a point, not on a line, there is one and only one line parallel to the given line. So if you have a point that's not on the same line as B, then there's only one line that you can draw through P so that the two lines are parallel to each other. Okay? Only one line. Yes. We did that. That was what we did right here. Oh, no. I just put a picture of of an acute, a right, and an obtuse. Just because that's what I had out there on the table. Yeah. I mean, I can put 2 in there, but it'd be basically the same idea. Add together and subtract. Okay, so what we demonstrated with the little triangles was the triangle angle sum theorem. Okay, this is the sum of the measures of the angles of a triangle is 180 degrees. Okay, so over here I've got that illustrated. Measure of angle A plus the measure of angle B plus the measure of angle C is 180. Okay, so we're going to find the values of x and y, and don't forget about vertical angles. What kind of relationship vertical angles have? They're congruent. Linear pairs add together to equal 180. And then if you've got parallel lines cut by a transversal, we have all those angle relationships that we're fixing to take a quiz over, right? Okay. So what might we find first? Yes. Okay. So we're going to look at this triangle here first, right? Okay. And so to find x, what are we going to do? Add 78 and 32, which is 110. So to get x, we're going to take 180 minus 110, and that gives me 7. Okay, so my x is 7. All right. Now I'm going to look at this triangle here, right? And what am I going to do to find y? Okay, it makes a linear pair with 78, doesn't it? Okay. So, to get y, I'm going to do 180 minus 78, which is 102 degrees. Okay, good. Okay, here's another one. What are the values of x and y in the figure? What should we find first? Yes, x, okay. So again, we're going to use the triangle angle sum theorem. And so to get x, what are we going to do? Add the 57 and the 59, which is what? 116. So we're going to do 180 minus 116, which is 64. Okay, so x is 64. All right. Now, what are we going to have to do to find y? I've got to first of all move my vertical angle over, so that's 64. And then we're going to do the angle sum, the triangle angle sum theorem again, right? So we're going to do 180 minus 106, which would be 74. All right, so pretty easy, right? Now, we're going to throw something else in here. And this is not hard. It's sometimes something that people forget about. It's the triangle exterior angle theorem. And it says that the measure of each exterior angle of the triangle equals the sum of the measures of its 2 remote interior angles. Okay, now, first of all, what's an exterior angle and what's remote interior angle? An exterior angle is an angle created outside the triangle when you extend one side of the triangle. Okay, so if I extend this blue line here, I create angle 1. It's created with the extension and the side of the triangle. Okay, so this right here is an exterior angle of the triangle. Then you have 3 interior angles, but 2 of them are considered remote interior. Okay, and remote means away from, because you use the remote control when you're away from your TV to change it, right? So remote means away from this exterior angle. All right, so these 2 are the remote interior angles. Okay, this theorem says that the exterior angle 1 is equal to the sum of the remote interior angles. All right. So, in this next example, to find angle 1, what would I do? Okay, these are my remote interior right here, aren't they? So I would do 75 plus 45, which is going to be 120. Okay, so this angle right here is 120 degrees. Yes? What? This right here?
That one.
That one's, no, because they're supplementary. So if this exterior angle is 120, this one's going to have to be 60, right? Okay. exterior angle, and they give you one of the remote interior angles, but not the other one. Okay? So we know that the exterior angle is 104, and how do you find the exterior angle? You add the other two together, right? X and 49. Okay, so the exterior is equal to the sum of the remote interior angle. And so then what would I do? Subtract 49 from both sides. And you get 55? You did. Okay, you get 55. Alright, one last one, and this one takes a little bit of thought. And it's important to read the directions. I tried to do it without reading the directions. Perplexed. Okay, Cheyenne built this display for her ornament collection. Each shelf is parallel to the base. Important piece of information. She recalls only the angle measures shown in the diagram. Now she wants to build another just like it. What are the measures of angle 1, 2, 3, and then I also want 45. Okay? Alright, so this piece of information I said that was important. The shelves are all parallel to the base. Okay? All of these are parallel to each other. Okay? And they just took out a portion of the picture. Okay? And so this right here is what we're dealing with. So if this is the base right here, then this is the only shelf really that's parallel to it. Okay? And so that I said is important. Alright. So I need to find 1, 2, 3, 4, and 5 basically. Alright. So what should I find first? 5? Okay. I would probably find 5 first, because I can use my triangle angle sum theorem. Okay? And so the measure of angle 5 is going to be 180 minus these two, which is what? 100. And so the measure of angle 5 is going to be 80. I'm going to write 80 in there. Okay. So what can we find next? Okay. Yeah, this right here is the top left angle. This is a vertical angle, so this is 80 right there. So you could go ahead and write that in there. Well, but this 75 is not vertical with the 4. It's not.
What's 75 and triangle?
It's not an exterior angle. It is an exterior. No. I don't think it is an exterior. No, it's not. Because it has to be an extension of one of the sides, and then it has to make an angle with the other side of the triangle. Remember the parallel lines. What if I drew this as my transversal? It's like I have this right here going on. Not one. One's not created by the parallel lines. But 2 is. 2 is like right here, right?
Are 2 and 5?
And this right here is like the 55, right? So would 2 be 55? Okay. So 2 is 55. Okay. So the measure of angle 2 is 55. Alright? Now I can find this little guy right here, couldn't I? Okay. So that would be 180
135.
minus 135, which is what?
45.
45. So this little guy right here is 45. And so now we could look at vertical angles. If we looked at this line here and this line here, what would angle 4 be?
45.
No, not 45. Look at what's created by those yellow lines.
It would be 75 plus 45.
It would be 75 plus 45, right? So the measure of angle 5 would be 75 plus 45, which is what? 120. Okay, so angle 4 is 120.
Use that to find the measure of angle 3.
Okay. Alright, so we can use that now to find the measure of angle 3. So now we're going to look at this triangle right here. Is that right?
Yeah.
Okay. Alright. So to get the measure of angle 3, then it would be 15 because I would do 180 minus 165. So the measure of angle 3 is 15.
So could you make,
Is it? Is it?
oh yeah, because that's a right.
How do you know?
I can't tell.
Let's look at it. Let's highlight it and see what happens. Let's look at this angle right here. I can't just say it looks like it's one, but if I look at that big triangle, is it a 90-degree angle right
Yeah.
here?
Because 245 equal 90.
Right. These 245 is 90, so that leaves 90 here, correct? Okay. So then to get the measure of angle 1, I could do
55 plus
90.
15.
55 plus 15, which is what? 70? And so it's 20. So the measure of angle 1. Wasn't that fun?
No.
That is the best part of geometry. I love it. It's like looking for a treasure or something. So that's my favorite part. Okay. I think there was another way that you could have done one. You could have yeah, you could have found this right here, which would have been 100, and then 100 plus 55. Well, yeah, you would have had to have done like 180 minus this to get this little piece right here.
Well, the also ones like bigger triangles still had
Yeah. You could have found this to be 60 because this is what 120. So this would have been 60, and then that would have been 20.
and 20 in that.
Yeah. Okay. And the way, like I said, there's sometimes more than one way to do it. All right. Okay. So we basically learned two things. We learned that all the angles of a triangle add up to equal 180. Okay. And the other thing that we learned was that the exterior angle is equal to the sum of the remote interior angles. Right. Okay. All right.